Okay, good evening. Can you hear me? Good evening. Okay, sorry, I was late because I came now. Okay, good. Okay, let's start. Heat lesson questions. Okay, first complete our worksheet questions. How many questions homework I gave in the May worksheet? How many questions we discussed? Dinod. We discussed first one, second one, 1, 2, 4 discussed. Then third one is homework. Okay, let's start from question number 3. The metal plate is 4 millimeter thick and the temperature difference between surfaces is about 32 Celsius. The temperature difference between two sides, it is 32 Celsius. Its conduct 840 kilojoules. It conducts 840 kilojoules heat per 1 hour to a cross section of 5 square centimeter. Find the coefficient of thermal conductivity. Coefficient of thermal conductivity means thermal conductivity. That means K. That means K. K. The question asks, what is the K of this metal? There is an unknown metal. There is an unknown metal with 4 millimeter thick and 5 square centimeter cross section area, and the temperature difference 32. The question asks, what is the K value? What's the K value? What's the K value? Okay, this is a question. Question number 3. This is a metal plate. This is a metal plate. 4 millimeter thickness. 4 millimeter thickness. This thickness 4 millimeter. And the cross section area 5 square centimeter. The cross section area 5 square centimeter. 5 square centimeter. And temperature difference, the delta theta 32 Celsius. Temperature difference also given, right? What else given data? Within 1 hour, yeah, that's the most important thing. Within 1 hour, it's transfer 840 kilojoule. 840 kilojoule, that means 840,000 joules. 840,000 joules. 840,000 joules within 1 hour mean within 1 hour 840,000. 840,000 joules. 840,000 joules. But if you want thermal conductivity in watt, what's the meaning of thermal conductivity in watt? the amount of heat energy flow into any solid object within 1 second, within unit time. Unit time means it is the time standard unit is seconds. Then you can find 1 hour mean 3600 seconds. Then 840,000 divided by 3600. Then you can get the amount of heat flow in within to solid object within 1 second per second, right? That is a watt. That's a watt per second. 0 to 0 cancel, 0 to 0 cancel. 8400 divided by 36. 8400 divided by 36. 233.33 watt. Yeah, very good. 233.33 watt. That means within 1 second, the amount of heat transfer 2233.33 joules. That's why we call it is 233.33 watt. Am I correct? Okay. But this is not the answer. This is the thermal conduction rate. You know, thermal conduction rate Q over T equal to Ka delta theta over L. This is our common equation, right? Q over T equal Ka into delta theta over L. Q over T means 233.33 equal K we don't know. K don't know. A mean cross section area 5 square centimeter. You can substitute 5 square centimeter. 5 you have to convert into square meter. 5 divide by 100 into 100. And delta theta 32, and the length is 4 millimeters. 4 millimeter. The thickness, the heat flowing through this thickness. The length is thickness. The length is the thickness. Then it is 4 millimeter means 0.04 meters. 0.004 because millimeters, 4 millimeters converted to meters divide by 1000. Divide by 1000. Right? Now I want to isolate K. Then how to isolate K? Now cross multiplication. Cross multiplication. K equal මෙහෙට multiply කරන්න 233.33 multiplied by 10,000 into 0.004 divide by 5 into 32. Now you can get the answer. Is a K. Is a K. What's the answer? 5 into 32 mean 160, no? 58 point, yeah, 58.3325. 58.3333 what m minus 1 k minus 1. Very good. What m minus 1 k minus 1 is a unit of the thermal conductivity. The unit of the thermal conductivity. This is question number 3 answer. Mariam? Understood? Afsal? Okay. Let's move into question number 5. Fourth one we already discussed last class. The composite wall is connected in a cold region by combining 5 centimeter thick layer of wood with a 10 centimeter thick layer of cement in order to maintain comfortable indoor temperature. Yeah, the composite wall is constructed in cold region, in cold countries like very low temperature environment. It's develop a composite wall to maintain the indoor temperature in normal condition, right? Normal condition. Indoor temperature, keep it normal, comfortable temperature, right? It's combining 5 centimeter. It's important. It's 5 centimeter thick layer of wood and 10 centimeter thick layer of cement. It's a composite wall, combined wall. The wall has a length 5 meter and width 3 meters. Right. The temperature inside of the house 25 Celsius while outside temperature 10 Celsius. Outside temperature 10 Celsius, but the indoor temperature, inside the house, we can maintain 25 ambient temperature, right? Comfortable temperature. The thermal conductivity of wood is 180 and the cement is 250. Assume steady state heat conduction and perfect thermal conduct between layers. Okay, what's the meaning of this within bracket part meaning? Assuming steady state heat conduction and perfect thermal conduct between layers. Again, the steady condition mean it's continuous. I think last day I explained the steady condition mean the amount of heat energy flowing enter within 1 second. Think within 1 second 10 joule enter to this rod. Within same time within 1 second 10 joule is waving out from this rod. Okay, that's the meaning of steady condition. Steady condition. The question given this composite wall thing as steady condition. It is in steady condition, right? Well, right. Calculate the temperature gradient across each layer of the wall. Okay, temperature gradient. Okay, before that, we can draw a diagram of this wall, right? Composite wall. Okay, this is a wall. This is a wall. Think this is a wall and it has 2 layers like this. Like this. Okay, inside temperature 25. Think this is the inside the house 25 Celsius and outside temperature 10 Celsius. 10 Celsius. Okay, then it is 10 centimeter concrete wall. It is 5 centimeter wood wall. Wood, it is cement. Cement. What else given data? Uh, the wall has length 5 meter and width 3 meters. Then what is the cross section area? The area of this wall equal 5 into 3 mean 15 square meter, right? This is the area. Area I got length into width because it's a rectangle shape. Rectangle shape. Then cross section area 5 into 3, 15 square meters. The temperature difference done, and the wood thermal conductivity 180 and cement thermal conductivity 250. Its thermal conductivity 180 watt m minus 1 k minus 1. Cement thermal conductivity 250 watt m minus 1 k minus 1. Okay, this is a diagram. This is a story. This is a wall. It's a composite wall. It's a composite wall. Right. In the question number 1, it is asking what is the temperature gradient? Temperature gradient throughout the composite composite wall. What is the temperature gradient? Temperature gradient equal, temperature gradient mean, what's the meaning of temperature gradient? Dule, what's the meaning of temperature gradient? The temperature gradient mean the temperature difference of unit length, then delta theta over L. Delta theta over L. The temperature difference of unit length. The temperature difference of unit length we called as the temperature difference. Temperature gradient, sorry. Temperature difference is 15 Celsius or Kelvin. Divide by length. What is the length? 10 centimeter plus 5 centimeter. It is 15 centimeter. 15 centimeter. 15 centimeter means 15 divided by 100. Now 15 multiplied by 100 over 15. 15 to 15 cancel out. 100 j k minus 1. Temperature, sorry, k minus 1. K minus 1 Kelvin per meter. Kelvin per meter. Correct? Dinul? Yeah, each layer we can't calculate behavior because we don't know, still we don't know intersurface temperature. If you found intersurface temperature, we can calculate each layer. But they give question given the heat energy transfer to steady conditions, right? Steady condition, then both layer, this is the answer. Both layer 100 K minus 1. Yeah, intersurface temperature asking in the next part, no? determine the temperature at the intersurface between wood and cement layers. Yeah. Intersurface temperature asking in the second part. Make it a temperature gradient. I got the common. Met me correct? You met? You know? Okay. Then let's move into second one. In the second one, the question asking what is the intersurface temperature? Intersurface means this contact surface temperature of this wall. Okay, how to calculate? Second one, Q over T. Okay, I'm going to first substitute our common equation into cement wall. Cement wall eකට දාන්න, right? Then K mean cement wall 250. A mean cross section area 15, right? Temperature difference theta minus 10. Theta minus 10. Why? The temperature, intersurface temperature greater than 10. Greater than 10. Because it middle, this one 10 Celsius, this one 25 Celsius. The theta is greater than 10. Therefore, theta minus 10 is the temperature difference. Divide by length. The cement wall thickness 10 centimeter. 10 centimeter means 0.1 meter. Right? This is my first equation. Okay, I'm going to substitute Q over T, our common equation, into wooden wall 180 into 15, same area. Now, what is the temperature difference? 25 minus theta, because theta is less than 25. 25 minus theta. 25 minus theta. Divide by the thickness is 5 centimeter. The thickness is 5 centimeter. Then it is 0.05 meter. This is my second equation. I told in steady condition. If it is steady condition, I told thermal conductivity rate Q over T common, same for both layers, both wall layers. Then first equation equal to second equation. First equation second equal to second equation. Now 250 into 15 into theta minus 10 over 0.1 equal to 180 into 15 into 25 minus theta divide by 0.05. 0.05. Now 15 to 15 cancel out because same. 15 to 15 cancel out. 0 to 0 cancel out. 0 to 0 cancel out. 0.1 to 0.05. It is 2. 2, right? 2 and 25, 12.5. It's easy. Better to cancel out. Okay. Now it is easy. I'm going to add brackets. Right. Now 12.5 into theta, 12.5 theta. 12.5 theta minus 12.5 into 10, 25. 25 equal 18 into 25. What is the answer? 18 into 25. 18 into 25. 450. 450. Minus 18 into theta. 18 theta. Now you can get theta terms into one side and values into another side. It is 12.5. 18 theta get into left side, then it is plus 8, 18 theta. 12.5 plus 18. Yeah. 12.5 into 10, 125. Yeah. Sorry. 125. Now okay. Okay, good. 12.5. 18 minus 18 get into left side. It is plus 18. 18 plus 12.5. What's the answer? 18 plus 12.5. 30.5. 30.5 theta equal 450. 400, 125 get into opposite side. Then 575. 575. Okay, now you can get the theta. Okay, the theta. Theta equal 18.85 Celsius. Okay, this is the intersurface temperature. Intersurface temperature 18.85. Any doubt, Dinul? Correct? Dule, clear? Correct? Mariam, Afsar? Okay. Okay, let's move into final part. Okay, calculation. Uh, Final one. Find the rate of heat flow through this entire wall. Okay, I told in steady condition mean both walls, the thermal conduction, the amount heat flow enter within unit time and leaving out within unit time is same. Therefore, the thermal conduction rate for both walls it is same, but thermal conductivity difference, thermal conduction rate same. Right now, you can get the thermal conduction rate for any wall. Any wall, you can get the thermal conduction rate because now you already know the intersurface temperature. Now Q over T, Ka into delta theta over L. K into A mean, okay, let's substitute values for concrete wall. It is 250. K value 250. 250. The cross section area 15 square meter. 15 square meter. Temperature difference it is 18.85. The 18.85. The outside temperature 10. Then 8.85 is the temperature difference, right? 8.85. Divide by the length of the concrete wall, cement wall, it is 10 centimeter. 10 centimeter means 0.1 meter, right? Now you can solve these values, solve this equation to get the Q over T. The Q over T means thermal conduction rate. Thermal conduction rate. 250 into 15 into 8.85 divide by 0.1. Get the answer. This 331,875. 875 watt. 331.875 kilowatt. Okay, within 1 second, this much amount of heat energy, 331,875 joules within 1 second flowing through this cross section of the wall. Flowing through the cross section of the wall. Understood? If you want within 1 hour, 1 minute, 1 day, the thermal energy transformation amount you can calculate by multiplying time. This value multiplying with time in seconds. As example, within 1 minute, the amount of heat flow amount is 331,875 multiplied by 60 seconds, right? Within 1 second, this is the amount. If you multiply by time in seconds, you can calculate the heat energy for any particular time period. Okay, Dimit? Okay. Now let's go into sixth one. To reduce the summer heat gain, a house roof is built with two layers. Two layers. 10 centimeter layer of clay tile and 15 centimeter layer of fiberglass insulation. Right? The total area of roof is 8 meters and 4 meters. 4 meters by, sorry, 8 meters by 4 meters. That means 32 square meters, right? On a hot day, the temperature of outside temperature surface of the roof reach 45 Celsius. The outside 45, while the temperature inside the house maintain at 22 Celsius. The thermal conductivity of clay tile is 1.3 and the fiberglass is 0.04. Assume that no heat loss to convection or radiation and steady heat transformation process, right? Steady heat transformation. Calculate the temperature of the intersurface of two surfaces. I got this intersurface temperature. What was the intersurface? Got that? Jimit, could you get this? The intersurface temperature asking. Again, same thing. Now the problem is, there is problem here. To reduce summer heat gain, a house roof is built two layers, 10 centimeter of layer of clay tile and 15 centimeter layer of fiberglass insulation. Which one is outer layer? It is not given. Outer layer, tile layer or fiberglass layer? Which one you got as outer layer? Clay tiles. හරි. අපි ඒ විදිහට මේක දෙන්න ඕනේ එහෙම. What is outer layer and inside wall? මේ wall it is not given. හරි. Now think this is a wall. This is a wall. It's two layers like this. It's two layers. Think this is a tile layer. No? This is a fiberglass layer. Fiberglass layer. Now its thickness are given 10 centimeter and 15 centimeter. 10 centimeter tile layer and 15 centimeter fiberglass layer. And outside temperature 45 and inside temperature 22. 45 Celsius and 22 Celsius. You know, heat energy always transfers from outside to inside. මෙහෙම තමයි heat energy again. Right. This is a heat energy flowing method. Always high temperature to low temperature. The thermal conductivity also given. Then 8 into 4 mean area of the wall is 32 square meter. That's the area. And thermal conductivity of tile and fiber separately given. .3 and 0.04. K equal, yeah. All data required given. Okay, in the first question, it is asking the intersurface temperature. Intersurface temperature. Okay, how to calculate? The intersurface temperature, Q over T equal delta Ka. Q over T equal Ka. Ka mean I'm going to first use this outer layer, tile layer 1.3 into cross section area 32 into the temperature difference. What's the temperature difference? 45 minus theta, because theta 45 is greater than theta. 45 minus theta. Divide by the length is thickness 10 centimeter. 10 centimeter mean 0.1 meter. Right. Now this is my first equation. Okay, get another equation. Q over T equal. Now substitute for fiberglass layer. Then it is 0.04 into 32, same cross section. Temperature difference theta minus 22 divide by 0.15 because 15 centimeter. This is my second equation. I told if it is steady condition, both thermal conductivity rates are same. Both thermal conductivity rates are same. Therefore, first equation equal to second equation. 1.3 into 32 into 45 minus theta divided by 0.1 equal 0.04 into 32 into theta minus 22 divided by 0.15. Right, just equal. Now 32 to 32 cancel. 0.1 to 2, 0.15 mean 3. Uh, 0.3 divided into 2. What is the answer? 0.65, right? Harmeet. Yeah. Yeah. Now 0.04 divided by 3. What's the answer? Zero point 0. Okay. It is complicated. No? Okay, let's get as it is. Hi. Now 0.65 into 45. 29.25 minus 0.65 theta equal 0.04 into theta, 0.04 theta minus 0.04 into 22. 0.88 divide by Okay, 29.25 minus 0.65 theta. Theta equals 0.04 into theta 0.04 theta minus 0.88 divided by 0.04 into 3. 0.12. Okay, this brackets. Okay, then how to isolate theta? Any idea? Okay, try to isolate the theta. What's the first step? Cross multiplication first. Cross multiplication both values. 29.25 multiplied by 0.12. It is 3.51 minus, again multiply 0.65 multiplied by 0.12, 0.078 equals same thing, 0.04 theta minus 0.88. Now you can isolate it. Get the theta value. Theta terms get into same direction. .43 equal so there's a theta here. Zero point 118 theta. Theta equal is it 44.53? Are you sure? There others, what is your answer? With me? What's your answer? Mariam? You met? 1.3 over 0.1. 0.04 divided by 0.15. I got. Hmm. Yeah, correct. It is 4.39. Sorry, mistake. Uh, but it is 37 point value. Come check again. Yeah, let me check. 1.3. Okay, better to I had the point 0.65 into 45. Hmm. Yeah, what's the problem? 0.04 theta, 88. Okay, let's do this step again. Okay, let's get this way. It's 3 and 0.04 cancel. It is 0.0133. Okay, let's do this way. 0.65 into 45. 29.25 minus 0.65 theta. 0.0133 theta minus 22. 0.2926. Then 2926 0.6633 theta. Yeah. Theta equal. Yeah, I think I have done mistake. 44.53 Celsius. Yeah, we are correct. Yeah, 44 point. Then it is very small temperature drop due to tile plate. The fiberglass plate is doing huge job. Huge job. It's a drop temperature from 44.5 to 22. It's doing huge drop. Huge job fiberglass layer because its thermal conductivity is very low, 0.04 compared to cement tile layer. Yes. Okay, intersurface temperature is done. Calculate the temperature gradient in each terms. Now you can calculate the temperature gradient in each terms. Each term. In the second part, tile layer, temperature gradient delta theta over L. Temperature difference it's very 0.47, right? 0.47 is the temperature difference. 0.47 Celsius or Kelvin is the temperature difference. What is the length? 10 centimeters, 0.1 meter. 0.1 meter. Okay, what's the answer? 4.7 km minus 1, right? Okay, then fiberglass layer, fiber layer, temperature gradient delta theta over L, temperature difference, it is 44.443, 22. What's the difference? It is 22.53. 22.53 divide by length. Length 15 centimeter. 15 centimeter means 0.15 meters. It is Kelvin. 22.53 divide by 0.15 meters. 150.2 km minus 1 temperature grade. Correct, Yumit? How you got minus, Dinul? Not minus, it is plus. Temperature gradient mean temperature difference mean always higher temperature minus lower temperature, not the final temperature minus initial temperature. It is 22.53. Okay, then not minus, it's plus. Okay. Okay. Part C. Calculate the total heat transfer rate into house through the roof. Calculate the total heat transfer. Calculate the total heat transfer rate into the house through the roof. Okay, the total thermal transformation rate mean, I told if it is steady condition, the thermal conduction rate of both layers same, then you can find Q over T for any layer. Q over T equal Ka into delta theta over L. The K is 0.04. What's the cross section? What's the cross section? 32 square meters. Temperature difference and temperature gradient you got 150 over 2, 150.2. Now you can get the thermal conduction rate. 150.2 into 32 into 0.04. 192.256 watt. Two more questions. A wall is made of two layers, 5 centimeter thick concrete layer and a layer of insulation whose thickness is unknown thickness. The wall is 4 meter wide and 3 meter height. 4 meter wide and 3 meter height, right? The inner surface is at 35 Celsius and the outer surface is 10 Celsius. The internal conductivity of concrete is, the thermal conductivity of concrete is 150 and the insulation has thermal conductivity 30. If the rate of heat transfer through the wall is measured to be 800 watt under steady state conditions, calculate the thickness of the insulation layer. Thickness of the insulation layer is asking. Okay, same type question, right? Now the thermal conduction rate is given. Thermal conduction rate is given Q over T. Ka delta theta over L. The thermal conduction rate is the thermal conduction rate is 1800. Okay, let's substitute first for concrete. Concrete 150. Inner surface 35 Celsius and outer surface 10 Celsius. They think the problem is yeah. But the problem is we don't know intersurface temperature. The intersurface temperature is not given. The intersurface temperature is not given. Like this. Think this is a wall. This thickness is not given and intersurface temperature also missing. And the area is given and inner surface 35 Celsius and outer surface is 10 Celsius. Outer surface 10 Celsius. Right. Now heat is flowing through this direction. Ka, thermal conductivity of concrete, it is 150. Cross section area is given, right? Cross section area is 4 into 3, 12. 12 into temperature difference, don't know. Theta minus, sorry, 35 minus theta. 35 minus theta. Divide by length. The length of concrete 5 centimeter. That means 0.05. Okay. Now you can find the intersurface temperature. Intersurface temperature. 0 to 0 cancel. 15 into 12. 180. 180 into 35 minus theta divided by 0.05. Now 180 to 180 cancel out. 1 equal 35 minus theta divided by 0.05. Now cross multiplication 0.05 equal 35 minus theta. Now 0.05 get into this side and theta this side, theta equal 35.05 Celsius. Sorry, subtract, not adding, 0.05 minus, right? Theta get into this side, it is theta plus 35 minus 0.05. So it is 34.95. Are you correct? 95 Celsius. Finger. Good. That's the intersurface temperature. But this question asking the thickness, the wall thickness. The wall thickness is asking. Unknown layer thickness is asking. Hi. Then what to do? Unknown layer thickness. To get the unknown layer thickness, you can just substitute common equation Q over T into K value. K value is given in the insulation layer, K value 30. 30 into A same 12, A 12. Temperature difference, now it is 10 and 34.95, 24.95 divide by thickness. Thickness we don't know, L don't know. And thermal conductivity rate, you already know, 1800 watt. 0 to 0 cancel. 180 equal 12 into 3, 36. 36 into 24.95. 898.2 over L. Now cross multiplication. 180 L equal 898.2. L equal, L mean thickness. The fiber insulation layer thickness. 898.2 divide by 180. It is 4.99. What is this mean? Impossible answer එකක් එන්නේ. 4.99 meters. It cannot be a wall, right? Thickness එක සෑහෙන්න තියෙන්න ඕන. Correct? Met me? You met? Let's move into final question. A composite wall is consists of cement layer and wooden layer joined together. Then the cement layer is 8 centimeter thick and has thermal conductivity 250. The thermal conductivity of wood is 180 and the internal and external temperature are 30 and 15 Celsius respectively. If the wall area is 6 square meter, the rate of heat flow is 2200 watt. Find the required thickness of wooden layer to maintain this heat flow. Same type question. Okay, think this is a wooden layer and cement layer. Thirty Celsius. Externally 15 Celsius. The thermal conduction rate also given. Q over T equal cement layer 8 centimeter, then at thermal conduction rate for cement layer. Q over T equal 2200 equal K value. Cement K value 250. Cross section area 6, no? 6 square meter. And temperature difference, now this is a cement layer. No, this is a cement layer, 8 centimeter. 8 centimeter, and it is 30 and 15 internal, external, sorry, internal and external, yes. Then 30 minus theta is the answer, temperature difference. Divide by 0.08 meters. To 20 equal 150. 0 cancel. 30 minus theta divided by 0.08. Now cross multiplication, 0.08 into 22. 1.76 equal 15 into 30. 450 minus 15 theta. Now you can isolate the theta. Now you can isolate the theta. 450 minus 1.76 divide by 15. Okay. Now you can get the theta. It is very small temperature difference, 29.88 Celsius. This is the intersurface temperature. This is the intersurface temperature. This theta equal 29.288. Correct? Right. Now, how to get this thickness? How to get the thickness? Again, substitute into equation with wooden layer. 2200 equal K. K value is 1180. Cross section area 6. What's the temperature difference of this layer? 29.88 minus 15. It is 14.88. Divide by distance or length. Now you can isolate. Now L equal 7.3. That one also meter. Both question. Okay, this is a L requirement. The length requirement. Okay. In heat lesson, all questions completed. Everything discussed. Tomorrow we'll start our new lesson, thermochemistry. Your exam not tomorrow. Exam. Let's do exam on a weekday evening. I will send the schedule. Exam is not tomorrow. Tomorrow we start our new lesson, thermochemistry. Very important lesson. Our first chemistry lesson starting from tomorrow. Thermochemistry. First chemistry lesson. I'll inform what is the exact date and time for your exam. You have a lot of heat lesson questions in the exam. So in these questions, what about round offing? Round offing where? Where got different values? Mhm. You're asking, yeah, round off mean you can, yeah. If it is round off, your answer will be slightly changed. But in mark scheme, no problem. In mark scheme, this round off answer also giving chances. No problem. Normally, every answers marking given for a range. Therefore, slight changes, no problem. Decimal value changes, no problem. Okay, then let's meet tomorrow morning with our new lesson, thermochemistry. So first question, third part, would I got? First question, third part mean? First question we did last day, no? Today first question. Question 3 or 5, you meant? 5. Hmm. It is 875. If you got using Q over T K value කියද මේක හොයන්න වෙනවා. Yeah, these answers change. Okay, these answers change. අපි වෙන්න මෙතන. It is not exactly 18.85, right? මේක දිගට එන answer එකක් නේද? Yeah, that's the problem. That's the problem. When we round off, yeah, that's the problem. එතන තමයි. If you got the exact value එක fraction එකක් විදිහට දාලා බලන්න, you can get the same answer for both layers. It's no problem. In marking schemes, no problem. It's okay. It's not error. It's not an error. Hard. Okay, then let's start new lesson, thermochemistry, our first chemistry lesson tomorrow morning. Goodbye, good night.